Knowing that the magnitude of the vertical force P is 2 kilonewton, determine the stress at point A and point B. Okay, this is my third attempt. I figured out every mistake I make, so let's do this together. So if I draw a free body diagram, no, that's super bad. I'm gonna do this again. If I draw a free body diagram of this guy, I know a couple things. So I'm gonna cut here. That's the equivalent of cutting here. So I'm gonna have my A here and my B here. You're not gonna see the other two. I'm gonna have my load P, that's 2 kilonewtons. So what are we gonna do? Well, we cut, so we're gonna have a load P prime coming out, and then we're going to have a moment like this. So what are we gonna do? Well, we're gonna say the sum of the forces in the y direction is equal to 0. So negative 2,000 newtons, or we'll just leave it kilonewtons, negative 2 kilonewtons, minus, see they're both negative, minus P1 is equal to 0, so P1 is equal to minus 2 kilonewtons, which is telling us, hey, you need to flip that, it's in compression. Okay. So where does that take us? Well, now let's think about the cross section. This is the cross section. We know it's going to bend along this. So this is going to be basically our Z, our datum, our neutral axis, because we're assuming this has homogeneous density. And so this is my 18 millimeters, and this is my 24 millimeters. So what am I going to do with this? Well, I'm going to calculate I about that axis, the neutral axis I just showed, which is going to be 1 over 12 times 24 millimeters times 18 millimeters to the third. So now what I'm going to do is I'm going to plug it into the calculator. I'm going to get 1 over 12 times 24 times 18 to the third, which is going to be 664 millimeters to the fourth. And now I realize that this is still my A and this is still my B. So if I'm going this way, and this is my y-axis, and this is my z-axis, then if I'm going that way, it's going to be a negative 9 millimeters. So I can say that sigma at A, now realize that it's an eccentric load. There's a component that's normal, the P, and then a component that's due to the couple. So what I'm going to do is I'm going to say that's P over A minus M about Z times Y over I about Z. Well, that's the moment of inertia. So now we have minus here, minus 2 kilonewtons, divided by the area, which is 24 millimeters, multiplied by 18 millimeters. And then we're going to subtract here. We're going to have our moment, which we didn't calculate. So the moment, the sum of the moments about the cut, we're in statics, so it's got to be equal to 0. So what's the moment of this guy? Well, about the neutral axis, this is the neutral axis, remember. Neutral axis, that's the equivalent of this guy right here. And so we want to look at this distance. We want to look at this distance. So what is this distance? Well, it's going to be this one. So we got our 40 and then another 9. So that's going to be 49 millimeters. So we'll put that in there. We'll put that into the sum of the cut is going to be, and it's going to be negative because it's going into the page, assuming that this is our reference system for this specific figure and for this specific view. And so we have a negative 2,000, or I can just say a minus 2 kilonewtons multiplied by 49 millimeters. And then I have another moment that's in the other direction. So that's in the positive direction, so that's equal to 0. So my moment is equal to 98 kilonewtons times millimeters. And so now I can put that here. And I can multiply by y, negative, because we're looking at A. See that purple arrow? So it's going to be negative 9 millimeters. All of that divided by I, which we calculated to be 1166 millimeters to the 4. So we get newtons over millimeters squared. Well, kilonewtons over millimeters squared. So let me write that. So we're going to have minus 2 over 24 times 18 minus, then we have another fraction. Top, we have 98 times negative 9. And at the bottom, we have 11664. So we get 7.1 times 10 to the negative 2. But remember, it was kilos, so we get basically 71. So 71 positive megapascals, because remember that newtons over millimeters squared is equal to megapascals. And this is going to be in tension because it's positive. So that's one of our answers. And now we do the same with the other one. So sigma B, well, it's going to be exactly the same here. We have the same internal load. That's usually the case for an eccentric load, but calculating the stress at a different point. And we have the same moment, but now we're going in the positive y direction. And I'll show you that over here. See, for B, we're going in this direction, which is the positive y direction. So if we plug that into the calculator, and we get minus 80.2. Minus 80.2, so that's compression. Fits with our intuition, and that's the answer. Ooh. I try to go fast because I just want to kind of get the reps in and kind of get you into doing it really fast. So I hope this was fast enough, and I'll see you next time.